So now we are going to compare some growth rates. So what are these growth rates? Last time I have presented this. So we have the O of 1, O of log n, O of n, O of n log n squared, n cube, and then 2 raised to n, which is the exponential. And this is arranged in the ascending order. All right. So if you remember, we had the f of n is in O of g of n, or being bounded by, or this function f of n is being bounded by O of g of n. So to understand that, if we look at this one, if we look at this graph, so if we say that f of n is being bounded by g of n, or f of n is in g of n, then it means that this g of n grows at least as fast as f of n. At least as fast as f of n. Meaning, mas, habang mas dumadami yung input mo, the running time will also grow bigger. Okay? With the same input of, for f of n and g of n will be greater. Okay? So we can then say that this f of n will be bounded by g of n, or f of n will be in g of n. Okay, now, if we have 3n plus 1, so it is being bounded by O of n. So how did we arrive to O of n? Do you remember? In the big O notation, if you remember, we were trying to get rid of the unnecessary parts or details, right? So if we have 3n plus 1, what we are going to do is to remove all the constants. So we will remove 1, and then we will remove 3, so we will be left with n. So n will be bounded by O of n, or n is in O of n, where the worst case is O of n. The running time will be O of n, I mean. So if we have 18 squared minus 50, it is bounded by O of n squared. So we will remove the constants, the 18 as well as the 50. So we will be left with n squared. And the running time will be O of n squared. And if we have 2 raised to n plus 30 times n raised to 6 plus 123, so it will be bounded by O of 2 raised to n. So why? Why is it 2 raised to n even if we have n raised to 6 here? So as we said, we will only focus on that part where it grows the most. Okay, so we will remove all the lower order, like 30 n's raised to 6 plus 123, and we will be left with 2 raised to n. So what about this one? 3n plus 1 is also being bounded by O of n squared. So that is true, right? Because if we remove all these constants, 3 and then 1, we'll be left with n. And n squared grows at least as fast as n. Okay? So even if we have the same input n, but the n squared will grow so much faster. Okay? The running time for n squared will grow so much faster, and it will always bound 3n plus 1. So we can then say that even if this is correct, but it is not tightly bound. What about 18n squared minus 50? So if you remember, we will only focus on the necessary part, so we will be left with n squared. So it will also be bounded by O of n cubed. So n squared will be bounded by n cubed. It is also correct because n cubed will grow at least as fast as n squared. It is correct, but it is not tightly bound. Okay, so what about this one? 4n squared minus 300n plus 12 is in O of n squared. So is this correct? So let's remove 300n and then 12 and then 4. So we will be left with n squared. So yes, it is correct, and it is also tightly bound. So what about this one? 4n squared minus 30n plus 12, the same function, is bounded by O of n cubed. So we already know that this is n squared. So And n squared is still bounded by n cubed. So this is correct, but it is not tightly bound. So how about the next one? 3 raised to n plus 5n squared minus 3n is being bounded by O of n squared. Is it correct or not? What are we supposed to do here? So we are going to remove all these terms, 5n squared and then 3n. Remove all the lower order because we can see 3 raised to n here and it's exponential. So let's focus on 3 raised to n. So this will be 3 raised to n left, and it is being bounded by O of n squared. Is it correct or not? No, it is not. Okay. Because n squared is much, much lower compared to 3 raised to n. Now, what about this one? 3 raised to n plus 5n squared minus 3n, the same equation, the same function, is it being bounded by O of 3 raised to n. And this time, it is now correct, and it is also tightly bound. So what if that same function is being bounded by 4 raised to n? So still it is correct, but it is not tightly bound. So what about this one? 50 times 2 raised to n times n squared plus 5n minus log of n. So what would be the answer here? So we are going to focus on this part. Okay, so is this being bounded by 2 raised to n? So in this case, it is wrong. Because as you can see, we still have 2 raised to n times n squared here. So we have to consider also the n squared na term. Right? So it is not correct and it is not tightly bound. But if we have 2 raised